Okay, good morning guys. So, padayon lang kita. So, nga diliwat ako number 9. So, this is about work energy theorem. So, for potential energy. So, you have number 9. A small rock with mass 0.2 kilogram is released from rest at point A. So, amin yung drawing. So, ginrelease ti kang didi, kutob nga di. So, which is at the top edge of a large hemispherical bowl. So, bowl in hiya with radius 0.5 meters. Now, assume that the size of the rock is small compared to R. Gutihan duro ni mo rock compared to your radius. Na-assume kita, gutihan ito duro. Kaya ano, something to do ito yan mo rigid body. So again, ito mo mechanics kasi na-assume kita ito rigid body. Di deformable body. Okay? Maliban ti pakatunat elasticity, ito, medyo nanti pakatunat ito topic iton non-rigidity. But anyway, may dangan nga ibang subject iton mechanics. Gibutang talaga tiya nga rigid body mechanics, not deformable body. To separate it from the strength of materials. Nga case. Okay? But anyway, another subject for that. Sunod nga iyo kuan, but hinahinay na akong pag-adjust. So, actually, pwede, hapit ako matempt nga kukuha ang kuan, um, ani mo ini nga iya length, hindi nga imo pole. Because that what our work is, force multiplied by this displacement. Di ba? But again, for amo yun gamiton, force is force times displacement. It imo force with respect to this displacement is a varying one. Actually, iba ito imo force nga dingan, iba ito imo as you move along that circle. So, medyo makurukor ito yung concept. 'Di ba? But rather, again, impasimple niya because again, maram kita nga this is a problem about potential energy. And you know that potential energy, kung naton lang kukuha niya concept nga, ani mo potential nga di minus ani mo potential nga di is just um, the minus sa nimo potential, that would be the total work. Total work. Ano mat na work ito nga da? Of course, your gravity, nga probably may da nimo friction nga na minus. But anyway, kung usa-usa nimo work, for example, letter A, between points A and B, by how much work is done on the rock, kita gimbulag mi an imo by friction and by gravity. So, wala man niya magsaring yung total work. So, pero kung nagpakiani ang total work, igma-minus mulot nga duha. Kay wari man, meaning, establish na yan na aton, nga kung sakasakali man, nag-aro yan total work, which is usually, amos talaga ito gamit. Kaya bangin, yan, para makaintindi kita at work, bubulag-bulago na nera. Para nakaintindi kita, anot work hang kuan, anot work hang kuan. So you could just imagine, if the total work is asked, ma-minus taan duduha, nga ma-work. Diba? Work ka mo kuan, nga, hindi din, bulag by gravity and by normal force ang una. By the normal force and then by gravity. Normal force and I by gravity. Normal force, mati ko, friction ano naging aro niya. Daw. Between the normal force, the normal force. So normal force ang una. So normal force, makikita ni mo normal force dito nga side. Your force is always against that displacement. So basically, ano mo normal force, that would be 0. Kaya normal to the inclined man. Diba? Waray ka man height or waray ka man height with respect to the normal force, because that normal force is always normal to this incline. Diba? Meaning, ano mo normal force, waray ito na trabaho. Okay? Waray. So, again, kita mo force nga directed towards the center, waray. May dahiya siguro, pausa-usa, pero ang imo bugos nga normal force from this point to this point would be a 0, 1. So, the answer would be 0. Hindi natin kailangan i-solve. Diba? O, iba man ang frictional force. Ang frictional force, lugod, may da. Kaya maka-counter hiya permanentity. Diba? Which is the opposite han imo gravitational force actually. Wala. Gravity lang ang normal force. Normal force by gravity. Okay. So, solve na kita. So, makati kita work total. Work total is just equal, ay sorry, work total lang din aaro. Ang work lang kuno nimo gravity is equal to potential energy which is mgy1 mgy1 minus mgy2. And then we can rule out that y2 is adha bottom, so this would give us a y2 which is 0. So 0 ito ya. Meaning tatong potential energy adila anak adila igbaw y1 nga of course ani mula radius adi. But this is just your radius because that is your height. Actually, y1. Ani mo, inihiya. Ini. Ini nga distance nga di, which is amo ini nga di. Diba nga da. So, that is just your R. So, kung R la ito iya, so, ready kita pag-substitute. So, WG, work on your gravity, ang ginaaro, is equal to positive iniya. Kaya again, may daniya higher potential. So, amo nga nito, gin-cancel ta ini kay an imo y to adha ubos. Okay? So, positive talaga ito. Basta adi hero ikpaw. So, you could just hinay-hinay pag-adjust. Ano ba? So, your M is 0.2 kilogram. 0.2 kilogram tapos 0.5. 0.2 kilogram tapos 0.5. So, you have 0.2 kilogram tapos 9.80665 meters per second squared. MGY1. Your Y1 is height, which is R. Pero to, 0.5, 0.05. 0.5 meters. So, you have 0.5 meters. So, you would have kilograms meters per second with Newton, and then meter. So, that would give you the work on gravity to be a positive 0.2 times 9.80665 times 0.5. And that would give us 0.98. 0.98. So, actually, 0.981. Depende iya problem kung tagtulo. Duha. I think duha latiya. Duha la ka significant figures. So, you should have a 0.98 joule for your work by gravity. And mo work by normal force would be equal to 0. Because your normal is normal to the incline. Waray trabaho ya. But frictional force, pag kita kumayda,